Hello again, and welcome to my second teaching presentation for John CV's CFI class. Today we'll be discussing transverse flow. Now, the importance of learning about transverse flow, unlike a couple other aerodynamics, I wouldn't even consider it so much a hazard, but it's the fact that we will be experiencing it on every flight. It's not a case of if it'll happen, it will happen. So it's important for us to know why it happens, when it'll happen, and how to correct for it. So in this lesson, we'll be discussing when it occurs, what happens during transverse flow, and how to correct for it. Okay. So basically, when it happens, it's pretty simple. It occurs upon initial takeoff, usually estimated between 10 and 20 knots. And what happens, I can demonstrate it here on my Mini R44, is that the nose of the helicopter will pitch up and it'll cause a roll to the right. Now, why this is happening is because that the aft portion of the rotor disc is basically just a spinning disc right here, is experiencing what we call some unclean air. It's basically some induced flow, and that's causing the angle of attack to decrease on the aft portion of the rotor disc. So there's less lift over here, and because of gyroscopic precession, which, as we know, is 90 degrees later, there is less lift on the right side as well. So basically, and at the same time, the lift at the front and the lift at the left is remaining the same. So we have a stronger lift force acting in the front, which is giving us that raise of the nose, as well as gyroscopic precession, which means a stronger lift force on the left, which gives us that pitch to the right. So once again, just looking at it from the back, you get a pitch up of the nose and a roll to the right. Okay, so just to further get you a better understanding of what happens, here is a diagram of both the forward and the aft or rear portion of the rotor disc. As you can see, the forward is not experiencing that unclean air, or induced flow as we call it, so it has a nice large angle of attack. Now the aft portion of the rotor disc, this red coming in, is the induced flow. And what that does is it significantly reduces the angle of attack, which is this blue line I've drawn here. So as you can see, the aft portion of the rotor disc has a significantly smaller angle of attack than the forward. So the forward has a greater amount of lift, causing that pitch up and roll to the right. Okay, so lastly, we have how to correct for induced flow. Now, just recently, the maneuver just recently changed. Originally, it was to give more forward cyclic, pushing the helicopter through, as well as lowering the collective and giving right pedal for trim. However, the maneuver was changed to be where the collective is left alone, and all that's given is more forward cyclic, and you can correct if there's any, uncommanded yaw or drift. then you can correct it with the pedals. But the main factor is giving more forward cyclic to get the rear portion of the rotor disc out of that induced flow. Okay, so we've gone over when transverse flow occurs, that's between 10 and 20 knots on initial takeoff. What happens? Induced flow is experienced in both the rear and right side of the helicopter, causing a pitch up and roll to the right. How to correct for it? You give more forward cyclic, pushing that helicopter through that induced flow and allowing it for effective transitional lift. Okay, so that wraps up my second presentation. Hope you enjoyed it.